Hello scholars, welcome back to the Kemet Maasai Academy. Today we're going to be looking at the Venn diagram. We're going to be shading the regions as they are described. Before I go any further though, let me ask you to subscribe if you have not yet done so. Just click that subscribe button and this will enable other students to access the videos. The more subscribers we have, the more the videos will pop up in the searches, and so more students can access them, and this is what we want. Also share the videos so that other students may benefit from the videos. So what we're going to be doing, we're just going to be looking at the set notation. If you're not familiar with set notation, we have a video just for that. Just go to the playlist and type in set notation and you will see the different symbols that are used in sets. So we're going to look at the notation and we're going to shade that region which applies. So let's start. We have two sets intersecting. Of course, these all indicate the universal set. So we all have our capital U at the top. The Venn diagram, the rectangle indicates the universal set, and then we have the sets, the circles on the inside to show the different sets and how they relate to each other. So X only, we're going to shade the region that is X only, not where X overlaps with Y. And this is how we would write it. X intersect Y complement, that's X only. So it's not going to include the intersection, so just this area, that is X only. How about Y only, or Y intersect X complement? The part of Y but not where it overlaps with X. So that would be here. That's Y only. How about X? Just X. So if we just want X, we're also talking about the part of X that includes Y, because that's X, right? Even the part that overlaps with Y is still X. So we would shade the entire circle of X, including the intersection. Now whenever we have a little stroke to the top right, that means complement, what is not in. So what's not in X? X complement. So we're going to shade everything outside of X, including the space in the Venn diagram on the outside of the circles. We're going to shade the part of Y that does not belong to X. And we're shading everything out here. Okay, what's not in X. So the complement of X, what's not in X. X intersect Y, where the two sets overlap. The intersection is right here in the middle. That's X intersect Y. How about bracket X intersect Y complement? So what's not in the complement of X and Y? Sorry, what's not in the intersection of X and Y? So everything outside of here. Everything in Y that's not in the intersection. Everything in X that's not in the intersection. As well as what's out here in the rest of the Venn diagram. So it's the opposite of this. So this one was saying X intersect Y, which is this little region. This one is saying X intersect Y complement. This is what is intersection, this is what's not in the intersection, including out here. X union Y, the union, what is in both X and Y together combined. So that's X, Y, as well as their intersection. That's the union. Everything in X, everything in Y, including their intersection. bracket x union y complement. So what's not in x or y? What's not in x or y? So that's just on the outside here. Still in the universal set, but not in x and not in y. The complement of x union y. Okay? So these two are opposite then. X union y, that's everything in x, everything in y, including their complement, including their intersection. X union y complement what's not in x, not in y. X is a subset of y, so this is a special case of intersection where everything in x is contained within y. When x is a subset of y, their union is y. So their union would have been everything here in the circles shaded, which is really y, because y is the bigger circle. And their intersection is x. So if we were asked to shade their intersection, we'd shade in here. If we were asked to shade their union, we'd shade in here and in here. Okay, special case subset where x is a subset of y, everything in x is contained within y. Special case of the intersection. Now, if two sets are disjoint, they do not intersect, they don't overlap, there's a space between them. Their intersection is the empty set, the null set. But if we're asked for their union, that we can shade, we just shade both sets. So the union of x and y, even though they are disjoint, they don't intersect, their union we can still shade. Each shade both of the sets. X intersects y intersects z. So this relates to three sets intersecting where the three of them overlap. So where x overlaps with y overlaps with z, that's right here in the middle. That's the intersection of the three sets and their union now. X union y union z. So we shade all three sets. And if we were asked for the complement of their union as we were here, it would be everything on the outside of the three sets. Right? So that's how we do the shaded region for sets. Just look at the notation, the set notation, and shade the region that applies. Okay? So if you want to replay the video, just do so and make yourself versed with these notations and the shaded region. Please subscribe if you have not done so as yet. Encourage others to subscribe so that other students may benefit from the videos just as you have benefited. And I will see you in the next video.